How about, wow, this one is on now, right? Okay. It is 10 a.m., so it is time to start the Ntp Working Group. We have I can do it with this. We're high tech. All right. So we'll go ahead and get started. This is the Ntp Working Group. We have a minute taker, thank you, Tal, and we have a jabber scribe, thank you, Rich. This is the note well. You will have agreed to it when you registered for the meeting, and it still applies. If you have any questions, feel free to ask us or the ADs. So this is our agenda for the day. We have, and we're at the agenda passing portion of the session. So there have been a number of changes from what was posted into the data tracker. So we'll have to go back and update that a little bit, but there has already been some bashing today. Any other agenda bashing? Nope. All right. So the first thing on the agenda is a quick review of the Ntp Working Group status for the documents that we won't be really discussing today. The first thing is that since the last meeting, we have requested publication of 2 of our drafts, the one on NTP packet timestamps and the one on NTS, so the Network Time Security draft. Thanks to Brian Haberman, we have the Mode 6 commands draft has been resurrected, and we're going to do a separate write-up on that. We will do a really short confirmation on the mailing list, but I believe the decision on this was to publish it as historic. And so that will be the plan for that document. Any questions there? Okay. The next one is the Yang data model. This one is ready for working group last call. Does anybody have any questions or comments on that? We will get that working group last call out this week. Given the holidays and everything, we will make it a 3-week working group last call. And if you have any questions, now would be a good time because the author is going to exit for another meeting shortly. All right, so there's no questions on that. Excellent. And then the remaining document that we have that we won't be discussing in more detail later today is the interleave modes. We did a working group last call on that, and that is still to be resolved as to where we're moving with that document. All right. So additionally, we do have 2 documents that have been adopted since the last meeting. And one is on rough time, and the other one is on the Chronos work that Netta was doing. There are no updates for either of those, so my request to the working group would be to start reviewing them. So we have agreed to develop these 2 documents. It's time to start making progress on them. Any questions on these 2 documents? Oh, okay. So at this point, the next document in the queue was the port randomization draft. And I know that there was an update to that. I don't know, we didn't actually receive slides from Fernando. I know he's here, but I don't think he's in the room. So, pardon? You don't think he's here? Why did I think he was here? Is he online? Okay. Well, in any event, there has been a fair amount of discussion of this draft, and it has been updated in advance of this meeting. So I would direct you to the mailing list to discuss any further issues on it. And next is on implementing time. Yes.
So this document sort of came out of a internship that Anchal Malhotra did with Inanna Labs to study the impact of vulnerabilities of NTP on DNS and DNSSEC to do an impact study. And we saw a few things which of vulnerabilities that could have been mitigated within the DNS software itself. So the applications did not use certain time values correctly. They did not choose the right clock to schedule periods, basically. And this document is intended to give some guidelines in how to do this, or to provide insight in what different, this is what I just told you. So you see in DNS there is the TTL for a certain DNS record. It's a period. We call this a relative time, instead of a specific point in time, which we call an absolute time. And DNS software, typically the not resolver, Power DNS, Bind9, Unbound, and DNS mask implemented this as taking the current world clock point of time and then adding the period to it and scheduling the expiry date for that point in time, which made it vulnerable for cache sticking attacks and cache expiration attacks. So in the documents, the scope is to explain what kind of methods there are to express time for applications. So the absolute points in times versus the periods, and the different clocks that are maintained by digital systems which may be used to deal with those different time mechanisms. And what the trade-offs are between using the one or the other. And it gives some guidance to help implementers make an informed choice. Right. We also have some description in the document on implementation approaches and an example how you can get the different clock times with a POSIX system and a Windows system. So the research results that we did, the impact study on DNS, was first presented at the IPG 2 years ago here in Singapore at the IETF 100. At the same time, we presented this draft, trying to provide guidance to application implementers. I think the working group was or wanted to work on this, but then there was a sort of critique on the terminology used in the draft at that moment. So we rewrote the complete terminology and made it to restrict it to be the bare minimum to describe the issues, which was presented 1 year later at the IETF 103 in Bangkok. And there were, I think, was received well by the working group. There were a few comments which I've merged into the document or addressed in the document, which was presented at the last IETF in Montreal. So that's where we are now. Yeah, so.
Okay, so between the last meeting and this one, we adopted this as a working group draft. Has anybody reviewed the draft that was published? Anybody? Are there any folk, I know that we are missing a number of our regular working group participants at this particular meeting. Is there anybody in the room that's willing to commit to reviewing this draft? There we go. Okay, there's Rich. Let's see in the back. So we have 3 volunteers. So excellent.
Okay.
Thank you very much.
So shall I submit it as a working group document now?
Yes, please.
Good. Thank you.
So this is going to be a short review about what is accomplished within NTS. At IETF 101, we started with a hackathon, the first hackathon for the NTS draft. That was, at that time, there were only 2 proof of concept implementation from Martin Lange and from Daniel Franke. And we had then following hackathons in IETF 102, we skipped 103, and in 104 we already had 4 implementation which proved interoperability. During the last 2 IETF meetings, we had 2 mini hackathons, so to speak, that have been basically the NetNode people who who did work on their Golang implementation of NTS. And this time, Krista was there to prepare scripts for monitoring the NTS operation and to write some how-tos. Service-wise, I've tried to compile a list of services, NTS services already available, and at this table you will see 6 available NTS services. The first one from the University of Ostfalia, which is basically Martin Lange. Then Cloudflare, who was the first to announce this actually. Then NetNode, who announced that recently. At my place, PTB, we also have a testbed currently running. And the Ntp Sec project has also NTS-enabled NTP servers. And there's also this NTP server in the last line, which I don't know which organization that is. Yeah, these services are basically, some are only for testing purposes. NetNode and Ntp Sec claims that's something between testing and production. If I would be careful to use the word production before the draft is finalized, actually. But it's already quite stable service. Then this is a table of GitHub repositories which are available for NTS implementations. And here are some more information about NTS, some blogs by Martin Lange or by Cloudflare and NetNode, how NTS is working and how to use it, and also by one document by the Ntp Sec project, in which they explain how to use NTS with their implementation. So I hope that's useful for those of you who want to do some testing or plan to work with NTS. Are there any questions?
Hi, Rich Souls, Akamai. Is it premature to try to get this in the client side into any of the Linux distros, do you think?
Into what?
Any of the Linux distributions, have they expressed interest, or is it still too early, do you think, to pick up a client side?
I suppose at least the NTS client is quite stable. And the NTS part in the Ntp Sec project is already part of the standard distribution. So perhaps there's a guy from Ntp Sector here who can elaborate on that.
Hi, my name is Sanjeev. Ntp Sec, the version which supports NTS is already in the Debian distribution, and downstream of it as well. It will be available in the new version will be available in 2004 in Ubuntu as well. I'm not sure about Fedora. Also has Ntp Sec, but their default client is Crony. So I'm not sure how many Fedora guys will install Ntp Sec, although Crony also has NTS support. So from the, however, this has to be enabled. So just having an NTS compatible client or server will not turn on NTS. Administrators have to still enable it.
Okay.
Any other questions? Deirdre and I have talked a little bit about ongoing activities to promote implementation and deployment. So we initially looked at the mailing list, and as some of these solidify, we will make announcements or point you to appropriate directions. So we put the Ntp v5 requirements on here as a discussion item. What we currently have is a list of items in a wiki, in the Ntp wiki. So I don't know, some of the key folks that would help lead this conversation are not here this time. So I guess what my ask to the working group is, if you go and you look at the Ntp wiki supported by the IETF, there is a number of Ntp v4 issues that have been identified. And so we haven't committed to doing an Ntp v5. That would obviously require more conversation within the community, but we are trying to gather the issues that we want to see solved. And so that work has begun at some level, and we should document it there. So any questions or comments?
Tal Mizrahi, is there a time goal?
Not yet. It's really we had been resisting it for a while. I think we wanted to get NTS out the door. And so I think in the next meeting or two, well, there is a goal in a sense that we have been talking for quite a while about combining NTP and TikTok and chartering a single time working group. So that is something that Suresh is smiling at me because we've been talking about it for a while.
I've been meeting for 4 years.
Right. So, and I think the context of discussing that charter will also talk about a timeline. But I think it's one of the challenges that I've found over the years in this working group is there's a lot of a lot of folks that'll tell you what we should be doing, but it's a real challenge to get people to step forward and write the documents. And so, developing a timeline for NTPv5 without people that are willing to actually write the documents is a challenge. So I think at this point we're really trying to clear off all of our things that we haven't gotten done, get them out the door, recharter, and then talk about a timeline. So, but in the meantime, we had a fairly robust conversation on this in our last virtual interim, and I think that doing that in the context of, I think it would be helpful to have those conversations when you go ahead and begin pulling the pieces together, identifying what we think we should solve and shouldn't solve. But there are a number of things that I think the other thing was there was a number of drafts that came through that the feeling was we kept trying to tweak things to fix them in V4, and the real answer was we just needed to move to a V5 and clean up some of the things that were causing us issues. Anyway, so that work is beginning. Please look at the wiki and go from there. Any other questions on V5? This is going to be the fastest NTP meeting in history. So go to the TikTok working group status. So as I mentioned, there is a TikTok working group, and the plan for that initially was, that's the wrong presentation. You need to go to the chair slides, I believe. It's the first tab. Down. Yeah, there you go. So the plan for the TikTok working group was to finish the enterprise profile for the PTP and close that working group. In the meantime, Jose has submitted an update of the draft that he had submitted previously. Unfortunately, and I do apologize to him, I didn't actually notice that draft had been submitted until early this morning. So I did not realize that there was an updated draft to discuss. So the status of the enterprise profile for PTP is that we need to get it resubmitted, and then we need to do the Shepherd write-up for it. So we have the XML for that, and it'll be moving forward. I'll talk a little bit in a few minutes about the status of PTP, which is relevant to that first enterprise profile. So the second document that is on the TikTok working group is Jose's, and I noticed that you are online. I don't know if you want to get in the queue to talk a little bit about what you've done in this update. I also noticed that you had been having audio issues, so that might not be possible. Go ahead, Jose.
Hi. Hi. Just to say that my draft, the update that we already done is we changed the format of the timestamp. We use now the timestamp format of the NTP, and we have to arrange the document. This is a new word that we don't do for the moment, but we are working a little slowly. We have few or any comment for the moment. I appreciate that if there are some comments. The central idea of the draft is to propose another kind of synchronization protocol different for NTP. It's more intended to synchronize two endpoints. We can synchronize several endpoints also. But the base is different because we send a packet for a second. It's different from NTP. And using this base and our filtering method, we can reach more precision in the frequency. And this is why trying to illustrate in the nexus that we added. And the idea, the central point with NTP is when you try to get NTP server in some country like Latin America or Africa, it's very difficult. You are not 20 milliseconds away. You are normally fast and farther than that. And this could be an option to make synchronization for clocks. The initial intention was to make some measurements in one way delay in IPP working group, and the IPP say me that TikTok is the good group to present this draft. This is why I am arrived to this working group. Well, this is a very fast resume for the status of my draft. Thank you.
Thank you. So as Jose has indicated, he has this is not NTP. This is a different type of synchronization mechanism. It was originally targeted at the TikTok working group. I think at this point we would move it to the Ntp working group, but we wouldn't adopt it until we resolve the charter issues. However, there have been a number of updates, and I think it would be helpful if folks would give it a review. It's only about 20 pages, so it's not too terribly long. Is there anybody that's willing to review this document? Anybody? I know a couple of the folks that were interested in it are not in the room. Excuse me. Are not in the room this morning. So at that point, thank you very much, Jose, and we will take this up at our next virtual meeting. Okay. All right. The last thing on the agenda is an update on 1588. I don't plan to go into I guess I should do the standing at the front. Okay, so what I actually wanted to do is just talk really quickly about 1588, because we have been providing briefs over the course of time about the status of 1588, and in particular the security work in 1588. So the basic timeline for this activity. So 1588 version 2 was published in 2008, and it included something called Annex K. The other thing you'll note is the 1588 MIB that we previously published was for 1588 version 2. So in 2013, we started the PAR for the 1588 revision. And in that context, there was a security subcommittee that started working on it. The basis of the work for that security subcommittee was the security requirements document that was developed here, RFC 7384. We had originally thought that the two solutions would be a little bit closer we had originally thought we would be able to reuse the two solutions between the two because they're both basically packet time synchronization protocols. It seemed like they were similar enough that we would be able to get some crossover. That's not where we ended up, but there's always hope for the future. And just like in the last week or so, the revision 1588 version 2.1 was approved for publication by the IEEE Standards Board, so it will be moving forward. It'll be coming out probably in early 2020, so you keep a lookout for that. So basically, the security approach that was used in 1588 was to include security mechanisms and guidance that could be used together or individually, and that the individual mechanisms would be optional. And one of the real challenges with 1588 was the number of different constituents that would bear. So you have the telecom community, you have the industrial automation community, you have a number of different communities like that, and they all have different perspectives on what their security solution should be. And the mechanism would be provided, and then the applications later would develop profiles, and based on those profiles is something that 1588 does in general. It does tailoring of the protocol for the different communities based on using profiles. And so the idea is that the same thing would happen for security, is that the different communities would tailor them differently. Basically, it is a multi-pronged approach, which has integrated security mechanism, which was added to version 2.1, an external transport security mechanisms, which was just some guidance talking about how external mechanisms that might already be in place could be used to help secure PTP, architectural guidance, and monitoring and maintenance. So if you look at the document, there's going to be a normative section, an option that is normative at 16.14, which is the mechanism itself. And then there's Annex S, which is all of the security material. So there is a PTP packet. There's a TLV that's been defined that includes the authentication TLV for security. It's been added to the PTP packet. That's the rough idea of it right there. All of the key management is currently left outside the scope of this document. And so there is some guidance on how to use Tesla, and there's some guidance on how to use GDOI, and they're used in different contexts for the two different approaches. Prong B is MACsec and IPsec as the two external security mechanisms that we thought might be present. And then redundancy is all of the architecture guidance that's provided, and then finally monitoring and management guidance. So all I really wanted to do here was to sort of point out that this work is ongoing. It is kicking off now that version 2.1 has been published. There is a plan to move forward, and there is some thoughts of using NTS in some form where it would be able to be reused to help the 1588 security pieces. So that was my quick update on 1588 since I've been talking about it before.
Suresh Krishnan. So is the IEEE expecting some kind of guidance from us for the use of IPsec and stuff like that, or they got it covered themselves?
They're not actually expecting any guidance. The way that particular that prong B was developed was two different communities came forward and said, this is how we're using IPsec in the context of, in that particular case, it was industrial automation types of applications. So it wasn't so much how should it be used, it was more like how are the systems that we are currently deploying are using this technology now.
Okay.
And it's a really pretty lightweight section. It's not providing a lot of specific guidance on how to use it, as much as it's saying that there is probably security mechanisms that exist in your system, and you need to think about how they interact with your time synchronization, because a lot of times folks deploy things and they don't think in the context of the impact that the security that exists all around of it has on the synchronization capabilities itself.
Okay.
So
I thought it could be useful, if I got somebody from the SEC area to take a look at it and see if there's something off, but if they don't want it, it's fine.
Not at this point, because it just got approved for publication. I have run it by individual security experts in the IETF, but I haven't run it through the security area officially because it
No,
wasn't.
that's fine. Like it's if we can help, let's.
Right.
I'll be glad to help. But yeah, it's fine.
Yeah, that'd be great. And as you know, there are issues with the accessibility of this document.
Yes, I'm acutely aware of it. Thank you.
So anyway, that's all I really wanted to do, is to provide you a quick snapshot. We've been talking about it previously, and then also to point out that there is some thought about how NTS might be used in this context. If you go back to some of the original documents around NTS, we had a general NTS specification, and the thought was the IETF would develop, NTS for NTP, and IEEE would develop NTS for 1588. That's not where we ended up, but I think there's moving forward, there's still some places where we can reuse technology, which would be really helpful. So with that, I think we're at the end of our agenda, and quite possibly the fastest NTP meeting ever. The area directors are happy about that. The one thing I did want to talk about was virtual interims going forward. We had planned last time to do 2. We managed to execute on 1. I think virtual interims really help us keep a pulse of getting our work done. So given that we're coming up into the holidays, we will probably be looking at 1 in early to mid-January. I think probably December is going to be a little bit too early. And there's a whole bunch of new documents that need review. So please, please, please start reviewing these documents and comment on the mailing list. And with that, any other questions, comments? There you go. We are adjourned.